So till now, we have looked at Python interpreters and we have looked at how we can test code quickly in Python interpreter. We've also seen how to write Python programs and then run it from the terminal. And we have seen enough of it. So now I wanted to show you notebooks because that's the most interactive and best way to explore either Python or in general data science or doing exploratory data analysis, training machine learning models. It's also good for storytelling. So that's why notebooks are very good. So let's look at notebooks. Then we will look at how we can take various types of arguments without actually being explicit. We'll look at the example and we'll look at higher order functions. So let's start with creating a new IPython file, a new notebook. So let's say we call it new notebook.ipynb. That's the extension of notebook. So this is how a notebook looks. So what we can do in notebooks is run code. I'll just give an example. This is the part where it's called a notebook. And these blocks, let me add a few more blocks. So see, these squares are called cells, and each cell could be a couple of lines of code or documentation or anything, right? So for example, this cell, right? At the bottom right, we can see Python written here. You can use it for any language. You can choose the language of your choice. But because this course focuses on data science and machine learning and Python, we'll choose Python. And there's another cell called Markdown. It's kind of like documentation, but it's very rich documentation. For example, I could write, this is documentation, and when I hit Shift plus Enter, this is how it looks. I could increase the size by using hash, and let's see. I can increase the size further by having 2 hash, although it's not visible here, but it does work that way. Similarly, if you wanted to have a bullet point or many bullet points, just use a dash, first point, then we can have second point. Let's see how it looks. Shift enter, right? Similarly, you can have like a tab and then a sub bullet point. See? So you can document it this way, and you can actually go to Google and search for Markdown commands, and you will see various Markdown commands, which includes adding an image, adding a link, adding a URL, and so on. But for now, this is a simple Markdown thing. This was the Markdown cell. Similarly, this is a Python cell, and we can write Python code here. Let's say a comment, then we can write print hello world. We can have a function called sum list, then have a list, then we can basically sum it for I in L s is equal to s plus 1 return s. Then we can print sum list and then pass on a list, let's say 1, 2, and 3. Let's run this. So when I run the first Python cell block, when I open the notebook, it will ask me where my Python is, and you can feed in your path. You can write it down, or you can choose if there is an option. For me, this is the one I am choosing, and it runs. So similar to interpreter, you can just write anything here and it runs. Additionally, what it does is, if I'm showing you some image or the plot, as it's very common in data science, it will just show the plot here as output. And there's also flow to it from top to bottom. So it's more like you show the order of analysis from top to down when you do the analysis. So this is notebook, and when you do a shift enter, it starts a new cell with the same type, for example, Python cell, and this one is a markdown cell. And of course, you can obviously convert a markdown cell to Python cell just by selecting Python. See, so this is it. So let's get started again with our Python tutorials. So there's also a shortcut here. If I just hover at the top of the cell, I can add a markdown or a code cell before this. So let's say I add a markdown. Now I can add a markdown, say args and keyword args. Let's clean this up. So now let's say I wanted to create a function where we don't already know the number of arguments we will feed. Def to define a function. Then let's say the function name is sum of many args. So one way to do it would have been like a list, and then again you create a list. But let's say you define a function which someone else is using, and every time it could be different for various reasons. So there's something called so how we write it is basically star args. So let's first print the type of it and see what it is. Type args, and then I call this function. Let's say 1, 2, 3, print it, run it. The first thing we can see here is that the type of args is tuple, and because we are not returning anything, it prints none. And we will return the sum soon. The speciality of this function is that here I had 3 arguments. Now I can have 4 also without changing anything in the function. See? And we can have 5 arguments and so on. Right? When we have variable number of parameters, we can use args. Now let's create the sum. So there's a simple sum function already in Python which we can use. So we'll just use sum args. Let's run it. See? So the sum of 1, 2, 3, 4, and 5 is 15. You can see how beautifully we can add more and more arguments with a comma, and it handles it. One more thing to notice is that these are positional arguments. So all the arguments which we want to be part of args tuple has to be at the beginning in this example, right? So I can additionally add one more variable, let's say 10, and the function will just run without any change. See? So let's take it out of it so that's very clear. Let's say s is equals to this. We print s, we run it. So what we can see is that we are not passing in a tuple. We are just passing in comma separated positional arguments, and it is able to handle it, right? So there's also another kind of argument which you can pass, which is named argument. Let's look at the example. Same. Let's say we define some many. Instead of args, we write keyword args. And for named arguments, keyword arguments, we use double star. Keyword args. Again, what we will do is just first print the type of keyword args and just call the function. Let's say equals 1, b is equal to 2. Let's run it. See? Okay, so we have actually, what we have done is we have printed keyword args, which we can see looks like a dictionary, but we will also print the type of it and actually see it in action. Comma keyword args. Let's run it. See, so the type of keyword args is dictionary, and we have printed it, and we want to sum as many. It could be anything, just a named argument, right? It could be 6, whatever. So the goal of this function is obviously to add all the values in this dictionary. So what we can do is we can return sum of keyword of dot values. We can print the result as is equals to this, then this 6, 7, 8, 9, 0, 9. So you can now see, and yeah, this named argument can be as many as you want. And for every run, it just works without any change. See? So this is about keyword arguments. This was about just positional arguments. And we can also combine it, right? Let's say we combine it. Let's call the new function def sum args keyword args. So how we write it is first we will have positional arguments, then we will have keyword arguments, and then we'll just first what we were doing before, we'll just look at the type of each type of keyword args. See, so when we combine it, first we see args is a tuple, and then keyword args is a dictionary. And now again, of course, I mean, this is what it was, but now we want to print the sum of it, right? The first thing I wanted to show is like, we could have any number of positional arguments, 1, 2, 3, 4, whatever number, as before. And after we have all the positional arguments we wanted, now we can start with named arguments. Whatever, right? Changes nothing. But the main point is that all the positional arguments should be before we start any of the keyword based argument, and all keyword based arguments comes together. All the positional arguments comes together, and this is how we run the script. Let's complete this function so that it returns the correct answer. So we will return first the sum from args, then we will add that number sum of keyword args dot values, and that's it. And if you verify, 5 plus 2 plus 1 plus 4 plus 3 plus 2 plus 1 is 18, right? So this is all about arbitrary number of positional or named arguments if you wanted to handle that. But yeah, this is all about positional arguments and keyword based arguments. Let's move on to higher order function. And of course, I mean, while I am showing this, you can see how a Python notebook works, right? And we'll be using this notebook throughout this course. So let's add a markdown before it and say we are starting a new section for higher order functions. Shift enter. So whenever I wanted to run a cell where I'm writing, I just press shift enter and it runs. And that's how I was running each one of them. Wherever I am, just shift enter, it runs. Shift enter, it runs. So click on the cell, shift enter. And if you want to run all of them together, just keep pressing shift enter, shift enter, shift enter, shift enter, shift enter. So if you do that, then there's also another option to click this button and it will run every cell in order from top to bottom. There's also an option to clear all outputs. See, all outputs are cleared. You can restart the notebook in a sense that there's a background Python binary running which powers all these scripts running. For example, if I press shift enter, it runs, right? And it runs in Python. So if you wanted to restart it for some reason, if it's stuck for some reason, you can restart it. And again, shift enter, it runs, shift enter, it runs. So this was all about it. And let's start with higher order functions. Let's start with higher order functions. So what is a higher order function? Okay. So earlier when we were using a function, we were passing some variables. Let's say x is an integer or s is a string, right? So a higher order function is just a function where input could be a function. So this is what in general higher order function is. So function being the first class citizen, just like int or string. And when we call this function, one of the arguments could be a function. I hope you understood what higher order function is. Let's see an example. Let's say we wanted to create a list of square of first five numbers. Right? Let's print it. Okay. We need x here. Right? 0 to 4, wanted a square. Let's say if I wanted a cube. We have a cube now. Now the point is that we are using some function here and which depends on the user what he wants to do. So user might want to do a square, user might want to do a cube, user might want to do an exponential. We don't know what it wants to do. And we want to create a function where user provides what he wants to do on each element. So something like what I would have wanted is user provides me the operation, which is a function, and I use that function on each value of x, and it gives me the list, right? So this is what I want. Let's see how we can achieve it. Let me add this to the comment so that we remember what we want to do. So let's define function apply operation, and it will operate on two things. One is operation and the second one is one input. We want to return a list where we operate operation of x for x in input. So this is what I wanted to do. Let's take two examples of functions which could become operations. One is square, another one could be cube, x to the power 3. You can say this, right? We'll pass these functions as operation. So let's use it once. So let's say my list is 1, 2, and 3, and let's print apply operation. The first input is operation, which could be a square. And the next input is the input, let's say L, and let's see what it gives me. See, square of 1 is 1, square of 2 is 4, square of 3 is 9. Similarly, I could also pass a cube because our function doesn't know what the user will pass. It's abstracted. So let's run that. See, it's cube. So this is an example of higher order function. There's one more thing I wanted to explain or introduce, which is called a lambda function. Basically, lambda functions are one-line functions which are not named, unnamed functions. And let's see how we could do that. So earlier we were passing this function cube, but instead of having the function cube, we could write lambda of x colon x cube. That's it. So first let's run it and then we will try to understand it. See, both of them are giving me the same answer. First one is taking a named function as input cube. Second one is just defining that cube function in line. So how we define an inline function is lambda space, all the arguments separated by comma, then colon. Then we use those arguments to find the value which the function should return. That is how lambda function is defined. Let's take one more function. which is also very common. So let's say I have a list called words, and let me create that list. Hello world, I am here dot split by space. We can print words and see. So this is my input, and I wanted to sort this by the length of the words. So let's say I create a new variable called sorted words. I use the function sorted. It's already defined in Python. The input is words, and we also provide the key on which it will sort. So for every item in the list, we need a value which will be used to sort it. So in this case, the value is length. So let's define a lambda function here, which takes the input word and then returns the length of that word. You'll see this. Let's print sorted words. So we can see, right? Earlier we had this list of words, a list of strings, and we use this sorted function, and we provided a lambda function which gives us value for each entry in the list so that we could sort it on a value, because sorting needs a value, right? So we can see it is sorted from smaller words to longer words. So that's another application of lambda function. Let's move on to a new function called filter. So basically we'll use three popular functions in Python which will come under higher order functions. First one is filter. What filter does is that we have a function which takes an input and returns true or false. And if I apply that function filter, one input is that function which returns true and false. Another input is a list of items on which that function will be applied, and final list which is returned will be all the items where that function returned true. So let's say what I want to do, right? Let's say I want to start with a list. Let's say first 30 numbers. See, so the input here is first 30 numbers, 0 to 29. And now my goal is that from this list, I want to only select those numbers which are prime. So let's first define a function is prime, which takes an input n. If n is less than equal to 1, then we return false. Then we'll kind of loop over the range 2 to n minus 1 and check whether n is divisible by 2, n is divisible by 3, n is divisible by 4, and so on till n minus 1. And whenever n is divisible by a number smaller than that, it is not prime, so return false. If all these are not happening, then we will return true. So this is the logic. So let's code that up. So range is from 2 to n. So if n modulo I is equal to 0, which means that it is divisible by I, then obviously it's not prime number. So we return false. And if it is not divisible by anything, then obviously it will be a prime number. So we return true. And if it is able to reach this line, then it is prime number. So this is the logic. Now let's look at filter in action. So prime numbers equals to, we convert to list, then we filter from the input all the prime numbers. So what we are doing here is that n is the input list, and what this filter is doing is it takes a function which returns true and false for every entry in n, and whenever it is true it includes, if it is false it excludes. Let's see the results. I wanted to print prime number. Let's run it. See. So for clarity, we'll just remove this. So from 1 to 30, these are the numbers which are prime. And let's see if I remove this list. What happens? Let's see. See. So filter returns a filter object which can be an iterator as well. So for example, I could have created x for x in prime numbers and it will give me the answer. I think you have understood. We have an input range. We define a function which takes an input and returns true or false. And filter is something which takes a function, operates on every element of the list, and if it is true, it includes, if it is not true, or if it is false, it excludes. And that filter is kind of an iterator which we could iterate on, or we could convert it to list as we were doing earlier. So this is what a filter is. Let's look at something called map. So map keyword kind of comes from map reduce, where you could have extreme level of parallelism. When let's say you have 1 million data points, you want to operate on every data point independently and in parallel. That's what mapper was. And in a similar way, if you want to have a one-to-one mapping, let's say I have a list L, and let's say that is 1, 2, and 3. So what a mapper does is, let's say I wanted an output, my desired output is 1, 4, and 9, or my desired output is sine of 1, sine of 2, sine of 3, right? So when the length of input and length of output is the same and there's a one-to-one mapping, we use the same function again and again. In the first output, we are using square, 1 square, 2 square, 3 square. Second output, sine 1, sine 2, sine 3, right? So what a map function helps us do, let's see. Square is equals to list, then map, then the first argument is a lambda function or a function. It could be a function called square which returns the square, but in this example, I will use lambda function and it just returns the square and the input is there. Let's print it and see. See, so what map is doing is it operates on every element and returns a list of same length. Let's say I wanted to have a slightly more complicated lambda function. Let's say this is L1. My L2 is, let's say, 1, 0, 1. And what I want is that I want to multiply element wise. So my desired output is, clear this up. My desired output will be 1 into 1, which is 1, 2 into 0, which is 0, 3 into 1, which is 3. This is my desired output. So again, we could use a map. Mul list is equals to list map. And inside map, what we will do, we'll first pass a lambda function. And this is the first lambda function we are doing where we have two arguments, x comma y. And we will do x into y, comma L1, comma L2. So see how map is working, right? We have seen positional arguments before. So this first part which is highlighted is the function which will operate on both of the inputs. Why both of the inputs? Because lambda function has two arguments. That's why we need two arguments after this, and it will take arguments with the same index, multiply it, and collect it into a list. Let's run it and see what we get. Print mul list, and we get 103, which was our desired output. Let's look at the final one in higher order functions. Let's add a markdown again. function is called reduce. Reduce. So the reduce function is actually in a library, and let's first import it. So there's a module called functools. So from functools, we want to import reduce. Now let's say my input is L is equals to 4, 2, 6, 5, 9, right? Now let's say I wanted to add all the numbers in this list, right? So what reduce basically does is it reduces a lot of data into a number. Let's say a maximum or a sum is an example of that. So let's say our output is equals to reduce. So reduce basically takes, again, similar to filter, but it operates in a very different way. That's why it needs a good explanation. But let's first write the code. So reduce's first argument is something which takes two arguments. Let's say x and y, and we want to add x and y. So first argument is a function, a lambda function, which just adds the two inputs. The second argument is L, and let's print it, and the sum would be 26. Now, what it is doing in the background, right? There's also a last argument which gives the initial value, let's say 0, and it gives the same results. But I could also start the sum from 10, and it will give me 36. So let's ignore this for now. The default value is none for that, and it starts from 0. So what it is doing is it starts with 0, right? Now, basically, it passes one of the running sum in this lambda function while doing it. So let's say I had a named lambda function called sum. S is equals to lambda x comma y colon x plus y. Pass here s. This is also a valid code because s is a lambda function or something which takes two arguments. If I run it, I get the same results. Now, what is happening? So there's a running sum. Let's say I call it sum. And first time, what it will do is s of 0, comma 4. Right? And the sum is obviously 4. So next time, what it will do is sum is equals to s of sum, comma, the next element, which is 2. Then again, it will do is sum is equals to s of sum, comma, 6, and so on. You get it, right? This is what reduce is doing. And we'll look at reduce function, we'll implement it in Python to see what it exactly is doing. And that function, which we will look at a bit later, will be a reduce function which takes one argument as a function, one argument as something called an iterable, and an initializer, which we saw, 3 arguments, right? We will implement it in Python and we'll see the answer. So that's it for this part.